Hello, my name is Natalia and I'm going to explain topic 10, which is applications of Newton's law. This lesson analyzes in detail the applications of Newton's law, which are fundamental for the physics branch of mechanics, particularly dynamics, which studies and analyzes the cases of the objects in movement. Comprehending and understanding Newton's laws and its applications is fundamental for the functioning of the systems in movement that exist in the lines of production. It is necessary to draw first the free body diagram and then the equations, describing either the movement of the object or its state of rest. For example, what is the tension T in the rope of the 10 kilograms block if it is accelerated upwards at 4 meters per second squared? What is the tension T if it is accelerated downwards? First, we draw the free body diagram. This is positive, this is our tension, mass times gravity. It is important that we show the direction of the acceleration on the diagram in order to put the correct sign in the equations. Since there are no horizontal forces, we must only do the sum of forces in y, and because we have acceleration in this axis, we don't have to equal to 0, but to mass by acceleration, because we are working with Newton's second law. So, the summatory of the forces in y equals to mass times acceleration. It's positive, so we put a positive sign. Tension minus mass times gravity equals to 10 times 4. Because 10 is our mass and 4 is our acceleration. So, positive tension minus 10, that is our mass, times 9.8, which is gravity. 10 times 4. So, tension minus 98 equals to 40. We're just clearing out 40. Equals 40 plus 98. So our tension is equal to 138 newtons. The rope is more stretched when the block accelerates upwards. The procedure for the acceleration downwards is the same, we just change the sign. So the summatory of forces in y equals to mass times acceleration. Now we're using a negative sign because we're trying to find the downwards. Now it's negative 40. Tension equals to negative 40. So tension equals to 58 newtons. Thus, when the acceleration is going down, the rope is less stressed even when it is at rest. Another example. In the absence of friction, what is the acceleration of the block on the 30-degree incline? So our incline equals to 30 degrees. In this exercise, we do a free body diagram, but we should rotate the axis in order to work easier. So the incline will be the x-axis, the normal will be in the y-axis, and the weight has an angle of 30 degrees with the vertical. So for example, if we have our incline like this, here's our force with a 30-degree incline. A force of weight and a normal force. But when we apply the 30-degree angle, so this is just this. Normal force. Here we have it in 60 degrees and here we have it in 30 degrees. Mass times gravity. The angle of the weight can be 30 degrees with the vertical or 60 degrees with the horizontal. The block is accelerated in the x-axis, so the sum is equals mass times acceleration.